Now, as we start topic 2 of chapter 5, we're going to be dealing with multiplication of polynomials. A couple of little background words, you probably know this already, but when we multiply, the items that we multiply are called the factors, and the results of multiplying factors give us a product. So this is what we're looking for throughout these as we go through these objectives of multiplying monomials, monomials and binomials, polynomials, the product of two binomials using that special method FOIL, squaring a binomial, then the products of sum and differences, and then we'll just do a little review of function notation. So a little review of multiplying monomials. Well, one of the first things you should do is determine what will the sign of your answer, the product, be. Well, if it's two positives that you're multiplying, it's going to be positive. But if one is positive and one is negative, your answer here will be negative. And the same thing here, a negative and a positive, the answer is going to be negative. So if you figure out your sign before you start, then you don't have to worry about the sign later. You already know what the sign will be. So 3 times 9 is 27. We determined it was going to be a positive. And now we just add our exponents. M to the third, m to the second, m to the fifth. Now keep in mind there is a 1 there. So n to the first, n to the sixth, n to the seventh. We already determined the sign. It's going to be negative. So this is going to be negative 7x. There's a 1 and a 1, so squared. Negative 21. A to the 11th. B, remember there's a 1 there, to the 6th. And then C to the 7th. 3 plus 4 is 7. Now let's just go over what's the degree of this monomial. Well, it would be the sum of these exponents. So the degree would be 12. Here it's 2. Here it's 17 and 7, 24. Just a little review. Now in example 2, what we're going to look at is multiplying a binomial by a monomial in each of these cases. And we're using that distributive law that we spoke of earlier. So this is going to be z squared, and this will be a negative 2z. This will be a 3z, remember there's a 1 there, cubed, plus 3 times 3 is 9, z squared. Adding your exponents. Now notice one of these is positive, one is negative, so we have to be careful of our signs. So 5 times 2 is 10, x to the fifth, adding your exponents, and then just the y. And then this will be a minus. 5 times 7 is 35, x squared. Now y to the third. Now here's where you need a strategy for doing this. So I'm going to go and show you again what I tend to prefer. So you can do this horizontally, but I think the best way to do it is vertically. So let me set it up that way. 4x squared plus 9x minus 3. Then we're going to multiply it by 2x minus 1. Now I did one of these the other day and I didn't copy it down correctly. Of course I got the wrong answer. Need to check you've copied it down. Now when we multiply vertically like this, we're going to take this -1 and multiply it by each of these terms. So this is going to be a plus 3. This will be a negative 9x. And this will be a negative 4x squared. Basically, we just changed all these signs. Now when we multiply this row, we have 2x times a negative 3. That will give us a negative 6x. Notice I put it in this column, which is the like term column. Now 2 times 9 is going to be a positive 18x squared. 2 times 9 is 18, x times x, x squared. And then now 2 times 4 is 8, x cubed. Notice I have a vertical column of where I put my like terms. So now when I go to add them up, 8x to the third, I'm going to subtract 4 here. That'll give me plus 14x squared. These are two negatives, so that's going to give me a negative 15x plus 3. And you can check your work. You want to be sure you get your best score on that test. So you want a method that gives you a high chance of getting the right answer. Now, in number or letter B here, it's exactly the same way. And in letter C, again, exactly the same way. The longer number on top, the shorter one on the bottom, line them up, get your vertical like term columns, and add them up. Okay, now over here in number 4, we're multiplying a binomial by a binomial. So one of the methods they spoke about up there was the FOIL. Now, many of you remember this from high school. The FOIL is just a way to multiply a binomial. The F stands for the first two terms, and you multiply those together, and that gives you an x squared. The O stands for the outer terms, which gives you an x times 4, which is a plus 4x. The I stands for the inner terms, which gives you a 3x. And the L stands for the last, which gives you a plus 12. Now often you do get two like terms in the middle that you would then combine like terms and get x squared plus 7x plus 12. Now you have what is called here a trinomial that came about from multiplying two binomials. Here, these binomials are referred to as factors that we spoke of earlier, and this is the product of multiplying these two binomials. We'll be using that skill here very shortly as we want to solve quadratic equations when you have a trinomial that's to the second degree and we equal it to 0. This is a quadratic equation in standard form. The technique we're going to use for that is to take this trinomial, factor it back into its binomial, and equal each factor to 0. We're getting a little ahead of ourselves, but this is where we're going. But right now, all you're doing is practicing the FOIL. Now, it takes a little while to master it if you don't know it already. Let's try this one. First will be 3x squared. Outers, a negative 3x. Inners, a positive 5x. And then last, a negative 5. Again, usually you end up with like terms in the middle. So this will be 3x squared plus 2x minus 5. Now, after a while, you can almost do this mentally, your inners and outers, and we often will be checking things by doing the FOIL. In example C, what you would do here is do the FOIL on two of them. So let's do this one. This is going to be, I'll write it up here, y squared. Now when I do my outers, I get a 3y, negative 3y, inners a positive 2y, which leaves me with a negative y for my middle term. I'm doing the outers and inners mentally. There's a negative 3y. There's a positive 2y. It leaves me with a negative 1y. And now I do my last, which is a negative 6. Now I have a trinomial. But I have to multiply it still by another binomial. So I put it down here. In fact, I'll even change colors. Y plus 4. And we're going to do this vertically. So now plus 4, negative 6 gives me a negative 24. 4 times a negative y, a negative 4y. And this gives me a positive 4y squared. Now, y times a negative 6 is a negative 6y, keeping it in my like term columns. This is going to be a negative 1y squared. Again, we don't usually write the 1, but it's a good thing to help you know exactly what you're doing. And then y times y squared is y cubed. Then we put our line and just add them up. Y cubed, this will be a positive 3y squared. This is going to be a negative 10y, and this is a negative 24. Again, we FOILed this, got our trinomial, and then multiplied it by the other binomial using vertical multiplication, putting our products as we did these individual items in like term columns, and then we just added up our results. Again, practice, and you want to get them right. A technique to help you, I believe, is this way here. Okay, now there are a couple of special ways that we will be multiplying things, and we often refer to these as special products. Let's put a U there. Now in special products, we use kind of like special ways. And here what we're doing is we are squaring a binomial. Now, one of the things you can always do is back up. Is just write it twice. So this will give you an answer. In fact, we'll do it. X times x is x squared. Your outers are 4x. Your inners are 4x. That gives you an 8x. And then your last gives you a plus 16. So that's always a backup way. You know, again, when you're taking a test, you want to get it right. But the way we want to feature in terms of a special product is doing it this way. Take the first term and square it. That gives you x squared. Now you're going to multiply these two terms together. That will give you a 4x. Now you double it. That gives you an 8x. And then you square this term, which gives you a 16. And you might say, wow, it's the same. Again, this is a special product where we use that special recipe for squaring a binomial. We square the first term, 9x squared. We multiply these two together. That's going to be a negative 6xy. We double it, negative 12xy. Square the last term. Negative 2y times negative 2y is a positive 4y squared. Okay, we're going to square this. I'll write it over here. That's going to be 4/9 x squared. We're going to multiply this together. Now we get a 2/3 y cubed. We have to multiply this by 2 to double it. That's going to give us a plus 4/3 x y cubed. And we're going to square this last term, and that gives us a plus y to the 6th. Y to the 3rd times y to the 3rd is y to the 6th. Now, you'll have some examples to work. Again, this is a backup way of doing it, where you can use the FOIL, but this is a special way of squaring a binomial. Now, these, when we square a binomial, form a special kind of trinomial, all of these. These are called, and you can write this down, perfect square trinomials. Now, in perfect square trinomials, later, if we recognize they are perfect square trinomials, they're going to factor into binomial squares. And what are some characteristics of these? Well, the first and last term in each of these are perfect squares. The middle term is gotten by taking the square root of this, which is 4, and doubling it. Take the square root of that, that's 3. Square root of that is 2. 2 times 3 is 6, and double it. And then this one's just a little bit tedious because of the fraction. Okay, so I'll take that off, but if you want to go back, watch it again, you're perfectly welcome to do so. Now, in number 6, we have another kind of thing, which is actually looks like this: a plus b, and then a minus b. So when the terms are the same as binomials, but one's the sum and one's the difference, when we FOIL this, a very special thing happens, and let's FOIL it. We get a squared minus ab plus ab minus b squared. Notice what happens to the middle terms. They just cancel out. And you end up with a squared minus b squared. Now, these individual terms like this have a special name. It's the product of the sum and difference of the same terms. These have a special name in regard to each other. They are called conjugates. And write this word down here. When we multiply conjugates, the middle terms always cancel out. And we get, this is again part of that special products, we get the difference of perfect squares. So anytime you have conjugates, as we see here, this one's a little bit tricky. I'll have to show you that one in a minute. But whenever you have conjugates, they're going to multiply into the difference of perfect squares. So again, no middle terms, just the first, which is t squared, and the last, which is a negative 49. Now, if you note that you have the difference of perfect squares, they will always factor later into their conjugates. So this one's a little bit tricky. I'll probably need to use a thing for it, but it's going to be, let's see, I know that's going to be x squared there. I just got to find out what that is, minus, and I think this is going to be 0.81 y to the fourth. I just have to figure out what 16 squared is and put the decimals in. And that would be 2.56. 0.16 squared is this. And I guess 16 is 256. That's not one that I know off the top of my head. Okay, now this next one, as we look at it, there's probably something you could do with it, but to be sure, I would just set this up as y plus 2 plus 4x, y plus 2 minus 4x. I would just set it up this way and watch for like terms. The other way might be is that, in a sense, this would be like y plus 2 squared, and then something, but I'm not going to go there. I would just do it this way. Well, I gave up a little early on that. Basically, this is what they should have listed here. And then it's this times this is going to be y plus 2, the quantity squared, squaring that. And then this is minus 16x squared. And then we just expand that. This term is y squared. Multiply these two together, double it, 4x plus 4, y I should say. Let's not put the wrong one in there. And then minus 16x squared. And I saw it down here too, which gave me a little hint how they wanted it. The other way would work too, but this is sort of what they wanted. Again, we didn't do a lot of practice examples, but that's what you're going to be doing as you work on your study plan. Okay, let's take a look at number 7 now. Here they're giving you this function, and they want you to do this function with these items. So let's set it up. So part of it is understanding what they want you to do. Here is your basic function, which I just copied in blue. Now they're saying for the x value, they're going to put an a there. So we're going to do that. This then becomes 3a, which will be squared, plus 5, replacing the x with the a. And then we had to add 2 to this, which I'm showing here. So we have a negative 9 plus 2 gives us a negative 7. And that's what they have here. Okay? So part of it's just understanding what they want you to do. This is the value of x, which is a. So you just replace the x with the a, and then they also want you to do this. Now in letter B, again, let me set this up. So all I'm doing, where the x is, they want you to substitute this, a plus 2. So where the x was up there, I'm putting in the a plus 2. And next to the 5, I'm putting in the a plus 2. So what I have to do is square that, keeping in mind I have a 3 there. So this becomes a squared. Multiply these two together, double it, plus 4a plus 4. And then this is going to be plus 5 times a plus 2 minus 9. So now I'm going to distribute. So I get here 3a squared plus 12a plus 12 plus 5a plus 10 minus 9. Now I group like terms. I have a 3a squared right there. I have a 12a and a 5a. That's going to give me a 17a. And then I have a 12 and a 10. I can do this subtraction here. I'm going to have a 1 left. So this is going to be 12 and 1 from this is going to be 13. So that was letter B, and that's what we have for B as well. Okay, now this one's a little more tricky, so I'll show you this in detail. Well, it gets a little bit tedious, so let me show you a little bit of it as we go along. So here we have this function where our x is going to have this value. So this is our basic expression. So we're going to put the a plus h where the x would be. X squared, a plus h squared, plus x, 5 times x here, and then minus 9. And then it says minus that same expression where we're just replacing the x up here with the a, which is what I've done here. So let's follow this down here a little bit. So this becomes 3a squared plus 5a minus 9. I guess we should have a little bracket over there that I now change to a parenthesis because there's a negative sign out in front. Now, to remove the parentheses with a negative in front, I just changed all of these. This was positive, now it's negative. This was positive, now it's negative. This was negative, now it's positive. And I'm going to work on this. So I'm going to take the 3 and distribute it. Get this, get that, get this. And now I'm going to do some collecting of like terms. Now you may be able to see that this negative 9 and this positive 9 just disappears. This negative 5a and this positive 5a just disappears. This negative 3a squared and this 3a squared disappears. So what I'm left with is 6ah plus 3h squared plus 5h. And lo and behold, that's what I have for an answer. And it did take me a while to do it, but I just want you to understand and become familiar with what working with functions are like, where they give you a value and then something to substitute. And again, we'll be studying this a little later as we do other modules. Well, good luck on this. It's 30 minutes, but there was a lot of stuff going on here.